Hello viewers, welcome to my channel ITJ Olympiads and AP Physics with Ambarish. And today I've brought another interesting challenge from Pathfinder for all of you. This is Build Your Understanding Problem 12 from Laws of Motion. And some of my students were facing a lot of difficulty in this problem. They were having some trouble with the concept involved, so that's why I thought that I'll take it up because it's a good illustration and application of concepts. So without much ado, let me straight away get into the problem. So here is the problem. The system shown in the figure is in equilibrium, so everything is at rest. This is a block of mass, some mass m, let's say. This is also, all the three blocks have been given as same to be of same masses, and the whole system is in equilibrium, so that means everything is at rest. Okay, this is in equilibrium. The blocks A, B and C are of equal masses. A, B, C equal mass. The inclined face is frictionless. This is frictionless surface. The pulleys are light and frictionless. The thread is light and inextensible. Okay, the thread is light. The entire thread is light and inextensible. The springs are light, and the blocks B and C are connected to axles of respective pulleys by rigid links. Okay, so this is a rigid link. It's not a string, it's a rigid link. Okay, so like a rigid rod you can think, and C also connected with a rigid rod. Okay, find the acceleration of the blocks A, B and C immediately after part A. The thread is cut at point P. So suppose we cut the thread, then we have to find the accelerations of all the three blocks, and part B is spring S is cut. Suppose instead we cut the spring S. Okay, so if you want you can give it a try. I'll get into the analysis right away. Let's see. So this angle was not given, but we are given that the system is in equilibrium. So my idea will be to find out this angle first of all. Okay, so this is a massless string. Let's say the tension in this string is T. So then and this block C is massive, and this is so an mg will be acting downward. So if this tension is T, this same string is continuing here, so this tension is also T. So what should be the tension in this spring? See, this spring force is balancing these two tensions plus mg. So this spring tension must be equal to 2T plus mg. Okay, and then the same tension T is going everywhere like this. So spring tension is also T. Okay, massless spring, massless strings. Okay, so now let me draw the FBD of A. So if I consider the FBD of A, we are having mg sin theta over here and spring tension T acting upwards, right? So T should be equal to mg sin theta because it's in equilibrium. Now what about the FBD of B? So B also has got same mass. So let's say mg is the weight of B. So mg should be equal to 2T. So 2T is equal to mg. That's equation 2. Okay. Now from equation 1 and 2 you can simply divide them, and you can find out sin theta comes out to be half. So theta comes out to be 30 degree. Okay, so we have inferred the angle of the incline. So this is 30 degree. Okay, and also if you solve for tension, that's the tension comes out to be mg by 2. So this tension is mg by 2. The T is mg by 2. So this is obviously this tension will be mg plus mg. So this tension will become 2 mg, right? So now coming to part A. So we have worked out the initial things. Now we can think about what happens when the string is cut at point P. See, so if the string is cut at point P, this tension must become 0, and when this tension becomes 0, then the spring tension must also become 0. And if the string tension becomes the spring tension becomes 0, that means what? The spring can suddenly contract, right? So so one thing you can remember is, if the contraction of the spring does not require sudden movement of any massive block, then obviously spring can contract. If it were to if the contraction of spring required movement of something massive all of a sudden, then that means what? Infinite force would be required, which cannot be given by spring, right? But for sudden contraction massless objects can have infinite acceleration subject to negligible force also. So what will happen? So if this tension becomes 0, this whole spring will contract all of a sudden. The tension in the spring will also become 0. Okay, so that's what I've written. The string is cut at point P, the tension throughout the string will become 0 and spring will contract immediately. Massless objects can have very large accelerations. Okay, so now what happens to the acceleration of A? So this is mg sin 30 degree downwards, and upward tension is 0. So mg sin 30 upon m is g by 2. So acceleration of A is g by 2 in the first case, right? Now what about the free body diagram of block B? So again both these tensions become 0. You see, this tension is 0, so this tension also becomes 0. So B is in free fall, right? So mg is acting, and therefore acceleration of B is simply mg downwards. Now coming to acceleration of C. Now look here in this figure once again. See, this spring is connected to a massive object. So C plus pulley is connected to a rigid, connected through a rigid link. That means what? This whole pulley plus C is a massive object, and therefore this spring cannot contract all of a sudden. Why? Because if this spring were to contract all of a sudden, then there will be infinite acceleration of this massive object C, right? Which is not possible because spring is offering only finite forces. So that means what? This spring is not going to contract all of a sudden until it is going to retain its tension. Whatever was before cutting the string at point P, same will be the tension immediately after cutting the string, because this cannot contract all of a sudden, otherwise C will have to have infinite acceleration, right? So this tension is retained. So this tension was what? 2T plus mg, and T we had found out as mg by 2. So that means what? This spring tension becomes total tension is 2T plus mg, that is 2 mg. You see where from this 2T plus mg is coming? It's same that we had before cutting of the spring, right? Cutting of the string at this point P. Okay. So now FBD of C is simple now. So 2T plus mg, that is 2 mg acting upwards, and of course mg is acting downwards. So now what's the acceleration? Acceleration of C will be simply 2 mg minus mg divided by m, that is g upwards. Okay, so what I have written, note that here the spring tension cannot change suddenly because that would require infinite acceleration of the massive object C. So as I explained just now. Okay, so this spring is not going to contract all of a sudden. Okay, so what's the key idea here? If no massive object needs to accelerate for contraction of a massless spring, the spring will contract suddenly. Okay. However, if the sudden contraction causes infinite acceleration of massive objects, sudden contraction cannot take place. Sudden contraction means immediate, happening in negligible time. Those kinds of contractions will not happen. Okay. So now coming to the B part. Okay. So this is now coming to the solution of the B part of the problem. Okay. So let's see. So now we have cut this spring. So when you have cut this spring can contract all of a sudden because its upper end can suddenly come down, and the tension in this spring will become all of a sudden 0. Let's call this tension as T double dash. So this tension becomes suddenly 0. So but what about this one? Can this spring contract all of a sudden? See, if this spring were to contract all of a sudden, then either B will have to go up all of a sudden or C will have to come down all of a sudden because of constraint. Because this much length is required for contraction of the spring. So if that much of length is required, then B will have to either suddenly move up or C will have to suddenly come down, or a combination of movement of these two massive objects. So that cannot happen. That means what? Here this spring will not retain its tension. This spring will not contract in negligible time, and the tension of this spring will be retained. Whereas this spring can contract all of a sudden because no massive objects need to move for contraction of that spring, right? So when spring S is cut, all of a sudden that spring will suddenly contract, causing the tension in it to be 0, whereas the spring on the incline cannot contract suddenly because that would require infinite accelerations of B or C or both. Okay, so these are massive objects and they cannot suddenly accelerate. Suddenly they cannot change their position all of a sudden. Okay, so tension in that spring will still remain the same because it cannot change its length all of a sudden, so tension remains the same, right? So what's the acceleration of A? Then it's simple. So A, there is mg by 2, and this tension was also mg by 2 as we showed in the initial part. So mg by 2 cancel off, and the acceleration of A comes out to be 0. Okay. Now what about the B? So B has got this tension mg by 2 acting above and mg acting downward. So acceleration of B will also be 0. Okay, because tension is retained in the string. Okay. Now what about acceleration of C? So for free body diagram of C, we can see the tension in the spring connecting to the C and this pulley system has become 0 because that spring itself was cut. So this tension becomes 0 and this tension are retained. They are coming from the spring. So spring is willing to contract. The spring on the incline is willing to contract to maintain its tension. Okay, as much as required. It's not contracting all of a sudden, but it will start contracting to maintain the tension. So long as the length of the spring is not changed significantly, the tension does not change significantly, right? So this tension is still mg by 2, and then there's mg acting downwards. So acceleration of C would be 2g downwards. Okay, so I hope you understood the analysis of this problem, and this helped you clear your concept. And if this video was helpful for you, please do give it a thumbs up, and please share this video as much as possible through WhatsApp, Telegram, Discord or whatever medium you use for networking your fellow students. Please make sure that you show this video to at least one of your friends, and you make at least one of your friends subscribe to my channel. That's most important thing. So most importantly, if you have yourself not subscribed to my channel, please do subscribe to my channel, because that's what keeps me motivated to bring out new videos for you frequently. And not only you should subscribe, please share this video with one of your friends and ask him to subscribe as well, if you think that it will help your friend also. Okay, and thanks a lot for watching this video, and I'll see you in the next one. And as always, God bless you all. Thank you.